All right, guys, a little bit of homework that we had due for today. Page 52, questions 7 to 14. We already looked at 1 to 6. We're looking at 7 to 14 here right now. Any issues with any of those questions 7 to 14? I know there was some issues with rearranging, right, with algebra, and that's why we spent first 20 minutes of class today looking at that. Any specific questions here? Yep. 13. Any others? That's it? Yeah, Tony? 8? Yep. 8, 12, 13, 14. So we got 8, 12, 13, 14. Going once, going twice. Sold on 8, 12, 13, 14. Number 8 says a train stopping distance, even when full emergency brakes are engaged, is 1.3 kilometers. So trains take a while to stop because they're heavy, right? They're heavy. If the train was traveling at an initial velocity of 90 kilometers per hour, hey, I'm going to circle that because I don't like seeing kilometers per hour here anymore. I want to probably end up converting that to meters per second. What's the acceleration under full emergency braking? Should have circled that as well. It's a group B problem, right? It's a group B problem because we've got this train slowing down. We've got this train stopping, in fact. We know that the displacement over which the train stops is 1.3 kilometers or 1,300 meters, right? Multiply 1.3 times 1,000, 1,300. We know that something is 90 kilometers per hour, which we're going to convert to meters per second in just a moment. But what is that that's 90 kilometers per hour? Is that V? Is that VI? Is that VF? Yep. Good. It's initial velocity, VI. Anything else if we read between the lines? Yep. Good. Final velocity is 0. We've talked about that a few times, right, where we have to read between the lines for a word as opposed to a number. Okay? It comes to a stop. It begins at rest, right? 0 meters per second for initial or final. Yep. Good question. Good question. Haley just said, if, by the way, we're looking for acceleration, right? Haley just said, if all the units are in kilometers, why would we need to convert it to meters per second? Technically, you don't. But understand, if you're leaving kilometers and hours as your units as you're calculating acceleration, then the units you get for acceleration won't be meters per second squared. They'll be kilometers per hour squared, okay? Which is technically valid, but it's a really, really odd unit for acceleration. So if you did that, as long as you put the proper units in for your final answer, I'd mark that correct. I would just, I would recommend not doing it that way because I think 9 times out of 10, if you leave it in kilometers and you leave it in hours, you're going to get an answer, and then because you're so used to meters per second squared, that's what you're going to put, and the answer's wrong then. Okay, so in my experience, we're better off just changing it to meters in seconds. And those velocity questions is a little bit different, right? Because kilometers per hour, when we get solve for V and it's kilometers per hour, I mean, that's pretty standard, right? Pretty typical. But acceleration, we don't usually see kilometers per hour squared. So, you know, we always, in these questions, we always really want to be in those base units. Yep. Yes, you could. Yeah, you could. But if you're having trouble converting kilometers per hour to meters per second, that becomes even uglier. It's not actually crazy. It's not ridiculous. But you know, anybody that struggles just a little bit in math is going to struggle on that one. But Lewis, yes, you can do that. All right. So what do I want to do here? I want to solve for A. I got VF. I got VI. I got D. What equation do you want to try here? Which equation would you like to try? It's a group B one, right? We know we got to pick one of those 5. Carrie? Good. You're close. You didn't say it quite right because it's not final velocity, it's final speed, right? But that's okay. We want to solve for A here. Good one. Good one. Good thing we just went over 20 minutes of rearranging equations. I want to solve for A. What's the first rule? Lewis, get it on the top. Is it on the top already? Perfect. What's the second rule? Second rule. Who haven't I called on today? Who have I not called on today? Seth, I don't think I've called on you, have I? What's the second rule? Good. What's not attached here? What's not attached to the A? Because I'm solving for A here, right? Okay, yeah, that's a 2, but the 2 is attached to it, right? 2 is multiplied by it, so it's attached. What's not attached to the A? VI, right? So let's get rid of the VI squared. It's added, so let's take it over to the other side by subtracting. By the way, I like your tie there, Seth. Yep. Oh, okay, good question. That's a very good question. The question was, isn't that speed, not velocity? Since we have velocity, shouldn't we be using an equation with speed? No, it's okay here to use this equation, even though that's speed, and we have velocity, because in the end, unless we're some kind of changing direction, velocity and speed are the same number, right? As long as it's the same number, we're okay. Does that make sense? Just that if we're not even told this is to the east or west, well, I guess we're told it's forward. We're just not going to plug the direction into that equation, that's all. Even if it was a negative value, we'd plug it in as a positive value because we plug it in as speed, not velocity. Okay, that make sense? Good question. Okay, still looking to solve for A. What's the next rule? What's the next rule? Lewis? Get rid of what is attached, right? And what's attached to the A? Good. So how do we get rid of that? Divide it. But don't just say VF squared over 2 times delta D, right? That's wrong. We've got to divide everything on the left side by 2 times delta D. And that equals A. Okay, so now we can go around and plug some numbers in here. Oh, we need this in meters per second. 90 kilometers is how many meters? 90 kilometers is how many meters? Not 9,000. 90 kilometers. How many meters? 90,000. 1 hour is how many seconds? 3,600. Do the division there. Lightning fast math in my head. It's going to work out to be 25 meters per second. Okay. How did I do that one so fast in my head? 90,000 divided by 3,600. Because I've seen 90 kilometers per hour a million times, and I just remembered that 90 kilometers per hour is 25 meters per second. So I cheated. Okay. In the end, that's how you still do it if you don't remember that. VF is 0. 0 squared minus 25 squared over 2 times 1,300. Let's do this on our calculator, okay? Do it as a group here. Let's say 0 squared minus 25 squared. Let's press equals there. Because what we've just done is calculated a number on the top. Now, let's get that number on the top, divide it by the number on the bottom. Let's use some brackets, though. 2 times 1,300 gives us negative 0.24. What does a negative value mean? Okay, it's slowing down, yeah. The acceleration is backwards or it's slowing down. Both of those work for us. So we should have predicted a negative number, right? That's what we got. All right. All right, 12, 13, and 14. 12 first. It says, determine the magnitude of a car's acceleration. The stopping distance is 39 meters for an initial speed of 97 kilometers per hour. Circle it. Use your ugly highlighter or whatever. Draw attention to the fact that it's something that's got to be changed. So what do we got here? 39 meters. What's that? Ryan, what's 39 meters there? Final what? No, 39 meters is not my final velocity. Okay. If its stopping distance is 39 meters, yep, it's my displacement. Okay, that's how far it took me to stop. Something's 97 kilometers per hour, although I am going to have to convert that to meters per second later on. Tell me what that is, please. Garrett? It's going to be VI. It's going to be your initial velocity or your initial speed. Stephanie, initial velocity, initial speed, doesn't really matter what you call it here, because in the end, we're not switching directions, so it's the same number, whether you're talking about speed or velocity. Is that it? What's the acceleration? Anything else that I have? If I read between the lines here, Alana? Good. VF is 0. Listen, you guys are good at this. Okay, you guys are good at finding those read between the lines variables. Okay, you guys are very good at it. You know, when it says starts at rest, VI is 0. Okay, it comes to a stop, VF is 0. You guys are better than a lot of classes that I've had at that. Okay, we need to spot those things. And thankfully, you guys do, for the most part, spot those things. Okay, we can't solve this problem if we don't know that. Let's convert this to meters per second. How many meters in 97 kilometers? 97,000, good. All right. How many seconds in 1 hour? Not 360. Art, how many seconds in 1 hour? In between, not 360, not 36,000, but 36, good. Now, if you forget that, that's okay. Just multiply 60 by 60, right? 60 seconds in a minute, 60 minutes in an hour, 60 times 60 is 3,600. I don't have this one memorized. What does that one work out to be? 26.94 meters per second. All right. Now I'm at the point of trying to find an equation. Which equation should I use? Zach, which one do you want to try here? Okay, okay. Which one do you want to try here? Brian? Yeah, you know what? That's the one that I would try as well. But in the end, we've said this a million times, right? If you pick one of the other group B equations, the worst that's going to happen is you're going to have to try again. You're not going to get the wrong answer. Just try again if you pick the wrong one. We're solving for A here. What's the first rule? Lewis, what's the first rule? Get rid of what's not attached. Yeah, sorry, you're right. Make it on top first, right? Is everything on top? Or is A on the top, I should say? Yes, good. Okay. Seth, what's the next rule? No, well, yeah, you know what? That was my fault because get rid of what's not attached, right? And VI is not attached. Now, how do I get rid of that? Good, excellent. So it becomes VF squared minus VI squared equals 2AD. You still want to solve for A. Got it on the top, got rid of what's not attached. Now we do what, Jordan? Get rid of what is attached. What's attached? 2 and a D. Might as well take them over at the same time. No reason why we can't. Don't have to, but we might as well. Lo and behold, there's acceleration. So A is equal to VF squared, 0 squared minus 26.94. This is almost like the last question, isn't it? Do the math there, guys. I'm not sure what we end up getting, but we do it in exactly the same way as we did the last question. Yep. All right, -9.3. Thank you, Lewis. All right, let's take a look at 13 now. A typical person can tolerate about 49 meters per second squared of acceleration. Okay, that's about 5 Gs. That's about what you'll experience on the Mindbender at the end of November when we're on our field trip. If you're in a car traveling at 110 kilometers per hour and have a collision with a solid, immovable object, over what minimum distance must you stop to not exceed this acceleration? Kilometers per hour, another one we got to convert. Seems like it happens with every question. And 13a is neg 49 meters per second squared. Something is 110 kilometers per hour, which we're going to turn around and convert to meters per second in just a moment here. What is 110 kilometers per hour? What is that one? What is that one going to be? Yeah, VI. Initial velocity, initial speed. Since we do have a direction here, let's call it velocity. Looking for displacement or distance, either one. Okay, it's the same value either way. Anything else? Reading between the lines. Is there anything else that we have given to us here, Seth? Good. Now we just got to find an equation here. Wait a second, isn't that going to be the same one as we used for the last one, VF squared? VF squared is equal to VI squared plus 2AD, but this time we're solving for D. Let's get this in meters per second first. 110 kilometers is 110,000 meters. Carry. 1 hour is how many seconds? 3,600. What is that, 30 point something? Give me an unrounded number, 30.555. We always want to go 3 or 4 or 5 decimal places, unless it's a final answer. Okay, rearrange and solve for D. Rule number 1, get it on the top, already done. Okay, rule number 2, Seth? Good. What's not attached to the D? VI. So let's get rid of that by subtracting. VF squared minus VI squared equals 2AD. Okay, rule number 3. Rule number 3. Really? Okay, good. What is attached? Good. Let's divide it by 2A. VF squared minus VI squared over 2 times A equals delta D. Let's calculate this one. We'll do this one as a group because it's a little bit different here. It's 0 squared minus 30.555 over 2 times negative 49. Let's say 0 squared minus 30.5555 squared. Whoops. 30.555 squared. Okay, let's divide that by, pay really close attention to this one, divided by brackets 2 times negative 49. Look at that, with all those numbers, we're still going to get a positive, with all those negatives, I should say, we still get a positive answer. We should. How far do you travel? You're traveling in a positive direction, so it should be a positive value, 9.5 meters. All right, finally, question number 14. It says determine a submarine's acceleration if its initial velocity is this. It travels 1.54 kilometers in a time of 2 minutes. Circled a couple non-standard units here. VI is 9.0 meters per second. Displacement is 1.54 kilometers, which is 1,540 meters. Our time is 2 minutes, which is 120 seconds. And we want to find the acceleration. If we read between the lines here, do we have anything else? I don't think so. I don't think we do here. What do you want to try here for our last kick at this? What do you want to try for this one? It's a group B problem, right? So we can't use V equals D over T. The rest of them are all valid. Pick one. Hopefully you pick the right one, but if not, that's okay. How about plus a half? Yeah, plus a half AT squared. You don't have to have the equation memorized completely because it's on your data sheet, right? If you know which one to use, then just check your data sheet and get the perfect form of it. Okay, oh boy, solving for A. Ugly. Not so bad, actually. Rule number one, Zach. Is it on the top already? Perfect. Rule number two. Ryan, what's rule number two? Good. What's not connected? What's not attached? Is there anything here that's not attached, Ryan? Good. VIT. How do you take that to the other side, Ryan? Good. So it becomes D minus VIT. Excellent. Okay. What's the next rule? Rule number three. What's rule number three, Allie? Good. What is attached? Good. Now we said there's a couple ways you can deal with this one, right? You can take the 1/2 over by multiplying by 2, or you can just take the half and the t squared over at the same time by dividing by both. Which one do you want to do? Same time? Okay. Since you're answering the question, you get to decide. D minus VIT over 1/2 t squared. That's not in the simplest form, but that doesn't matter. Okay, that's correct. We've just solved for A there. Let's plug some numbers in, though. D is 1540 minus 9.0 times a time of 120 over a half as 120 squared. Boy, we really want to pull up the calculator for this one. Okay, focus up here for a minute, guys. 1540, subtract, let's use some brackets here, 9 times 120. Let's get that number on the top. Number on the top is 460. Let's divide that by, use some brackets for the bottom, 0.5 times 120 squared, and the bracket, 0.64, 0.064. That's a pretty small acceleration, but we are talking about a submarine too, right? Submarines are not going to, under the water, are not going to go from 0 to 100 in 5 seconds, right? Your strength at the beginning of this day was picking out things like starts at rest, comes to a stop, goes reading between the lines thing, right? I think you have another strength now. I think rearranging equations is one of them. You guys are doing fantastic with this after we've spent that 20 minutes going over that stuff. You guys are doing great. If you're still a little bit puzzled about how to do that, okay, then ask me questions. Okay, come and see me for extra help, and I can help you with it as much as we need to. Okay, that's a pretty important skill that we have to have through Physics 20 and Physics 30, right? All right, while we're on the topic of acceleration, we're going to extend it just a little bit and talk about a very specific kind of acceleration here. The acceleration because of gravity. I have two sons, one's 3, one's 11. The one that's 11, when he was little, I think he was 2 years old or 3 years old at the time. I can't remember exactly how old he was. I remember he was playing with his toys, and he dropped something, and he was getting frustrated because this thing he was trying to build kept falling. And he said, I forget exactly what his question was, but it was basically to the effect of, like, why does this keep falling on me? And I said, well, Andrew, it's gravity. Like, gravity, without trying to get too scientific on him, I try to explain to him that, like, gravity will always cause things to fall. Gravity always pulls things down. So a couple days later, he's doing something and something falls and he throws a little temper tantrum. He stomps his feet. I hate gravity, he says. Even at 2 years old or 3 years old, kids know that gravity pulls things down. And although we might not consciously think of it, we all know that gravity causes things to not only fall downwards, but to accelerate downwards, right? Not move at a constant velocity, but speed up as they go downwards. That's why you can drop a coin from the top of your desk, but you're not allowed to drop a coin from the top of the Empire State Building because it accelerates as it goes downward. Keeps moving faster and faster and faster. Obviously, it would cause a lot more damage if it fell from the Empire State Building from your desk. Gravity causes acceleration. But how much acceleration? Everything that is under the influence of just gravity. In other words, if there's no air resistance or something like, or wind or anything like that, then everything will fall at 9.81, accelerate at 9.81 meters per second squared. Now, when I did the demonstration just a minute ago with the keys and the paper, when I held out the piece of paper, just that flat piece of paper, you guys all said the keys would hit first. You guys all said the keys would accelerate quicker, basically. When I crumpled up the paper, we found that they both accelerated at the same rate because I minimized air resistance then. I took away air resistance out of the equation. In the absence of air resistance, things will all fall at negative 9.81 meters per second squared. Anybody want to take a little stab at why we stick that negative in front? Yep. Yes, because it's falling downwards. It's accelerating downwards. It's speeding up, but it's speeding up downwards. Wait a second. All rising objects under the influence of gravity also accelerate at negative 9.81 meters per second squared. Carrie, shouldn't that be a positive? If it's going upwards? No, it's negative as well. Why? Well, let me throw this piece of paper, this crumpled up piece of paper, back up into the air. It goes up and it comes back down. As it's falling, clearly we all agree, I think, that it accelerates at negative because it's speeding up in the downward direction. But as it's rising, what's it doing? Yep. It's slowing down. So if you have an acceleration if you're speeding up in the negative direction or slowing down in the positive direction, it doesn't matter. It's the same acceleration. It's a downward acceleration. Even as this paper goes up into the air, it's a downward or a negative acceleration because it's slowing down in that positive direction. In general, acceleration is negative when it slows down in a positive direction or speeds up in the negative direction. Okay. Clearly, it's applicable to gravity, but we see that in other places as well, where we have a negative acceleration or a positive acceleration. A couple summers ago, my brother-in-law and sister-in-law have a trailer out at a place called Maple Lake in BC. Anybody ever been to Maple Lake in BC? Yes? It's a beautiful lake. It's huge and it's nice and secluded for the most part, except at this resort area. Beautiful, beautiful lake. Its deepest point is almost 800 feet. So it's 800 feet that's a deep, deep, deep lake, and it's beautiful, clear water. Go boating in the lake, and there's all kinds of things to see. Like all kinds of wilderness things to see. There's First Nations pictographs in a couple of different places that you can see. And there's a couple places where you can go cliff jumping into the water. It's great. Remember the first time I was out there and we went boating and then we went cliff jumping, I thought, goodness, like I'm jumping. Here's the water down here. Here's the cliff up here, right? I'm going to jump off this ledge into this water. Like, goodness, like it's just into the edge of the water. Like it's not going to be deep enough. Well, the lake goes down like this. It's literally, you park your boat right here. It's 100 meters deep right there, literally 100 meters deep. So you don't ever have to worry about hitting the bottom when you jump off this cliff. I remember sitting in the boat right here, sitting in the boat right there. My nephew, who was the one that wanted to go cliff jumping this day, says, let's go over here. My brother-in-law pulls up in the boat and says, I look at it and think, oh, that doesn't seem that high. Like that cliff doesn't look all that high. I can do that. So I scale this cliff. There's kind of a way that you can get up there. So I scale this cliff. I get to the top and I realize, look down and I think, oh, it's a lot higher from up here than it is from down here. So I'm up there. It probably took me, probably 10 or 15 minutes the first time to actually jump, to actually get the courage to jump. But I had to go because the way that you climb up the cliff, there's no way you can climb down that way. Like there's no way you'd be able to climb down that way. So I had to go. It's just a matter of getting the courage to go. Finally, I went, and then it's kind of one of those things, once you go, you're like, that was a blast. Like, that was so fun. I'm going to do that again. It's just the courage to do it once, right? And I said at one point, I said to my brother-in-law, how high is this cliff anyways? And he said, I don't know. He says, I think it's about 40 feet. I said, so how do you know? He says, I'm just looking at it. It looks like it's about 40 feet. I'm like, I could do that. I could look at it and say it's about whatever. Well, how are we going to figure out exactly how high it is? So here's what we did. We took a rock. We didn't throw it downwards at 4 meters per second because I don't know why you do that, actually. If you want to find out how high the cliff is, I don't know why you'd throw it because you have to know the initial speed. The easiest way to know the initial speed is to drop it. What's the initial speed then? 0. 0, right? And we timed it. All we have to do is time it. We have to time it, and we have to know the acceleration due to gravity, and we can calculate how far it fell. Let's just finish this question, then I'll let you go, okay? So let's do this now, okay? We're going to say VI is -4. Why -4? Because it's being thrown downward. It's thrown straight down at 4 meters per second squared, or 4 meters per second. T is 2.50 seconds. We know the acceleration is -9.81 meters per second squared. We want to find the displacement of this rock. Let's say D is equal to, it's a group B problem, right? It's exactly what we've been doing, except this time the acceleration is -9.81. It's exactly the same, other than we always know the acceleration. VI is -4. T is 2.5. Okay, let's do this one on the calculator as well here. Let's say -4 times 2.5 gives me -10. Let's add to that, let's use some brackets here, 0.5 times -9.81, don't forget the negative there, times 2.5 squared. Negative what? Why negative? The height of a cliff can't be negative, can it? We haven't found the height of the cliff. What do we find? What did we find, Lewis? We found the displacement of the rock. But what's the height of the cliff? 40.7 meters, right? However far the rock fell, right? If you left it as -40.7, that's fine. You make it positive, that's fine. I'll accept either answer there. Got it? Okay, here's your homework for tonight, guys. This is it. Page 58, questions 1 to 3. All right? Have a good night, guys.